Hello and welcome to the next video in my series of how to learn the Arduino. In the last video we covered the basics of Arduino, what it is, and some of the very simple things on how to do with it. In this video we're going to be covering RGB lights. I know I said before that there was probably going to be about 6 videos in this series. I think I've decided to extend it out and I'm going to try to make some of the videos smaller so they're a little bit easier to digest. I don't think a lot of people want to listen to a 40-minute video on how to do Arduino stuff. I'm also going to do some things to try to make them a little more interesting. I'll try to throw in some cuts of some other random footage, kind of like this guy right here, which you can see knows a lot of stuff because he has a man bun and he's staring at a glass board with a white marker on it. The first thing that we're going to go over is what I like to think of as the Franken diode. It is the RGB LED. These are really cool little devices. What they are is basically if you took a red, a green, and a blue LED, and you took either the anode or the cathode of them and soldered them all together, that's exactly what this is, but it's in one tiny little package. So you actually have them really close together, and if you combine the lights together, you get different colors, and you have the ability to make almost any color with it. Okay, so what does that actually mean? Well, you can see here on the common cathode LED on the left, these are actually the most common. I feel like you have a lot more control over these ones. You can tell that there's a pin for red, a pin for green, a pin for blue, and then a common cathode, hence the name. So what happens is, if you want to look at it in a schematic view, it's sitting right next to it here. If you send a current through the red leg, it turns on the red LED inside of the little thing here. If you want green, it turns it on here. And if you want blue, it turns it on here. If you want yellow, you turn on green and blue, and so on and so forth. There is also the common anode version of these. It has a common anode, obviously, and it has separate cathodes for each one. Here is the circuit we're going to be building today. I noticed in the last video that the overhead camera shot just showed my hands. You couldn't actually tell what was going on. Things were too small. I need to find a better way to record that if I'm going to try to do that in the future. I don't think that my webcam is nearly up to the task to pull that off. So instead of doing that, I figured this time we'll try using a pictorial diagram like this of the breadboard showing exactly how everything's hooked up. I'm hoping that this will do a better job of showing you the way that it needs to be hooked up. First thing to start with is the RGB LED itself. There's 4 legs on it. We've gone over them once already, but remember the longest leg is the common leg. That one is here, the second from the left in this drawing. That needs to be hooked directly to our ground because it is a common cathode. Then each of the other ones are a small LED inside of here, as we said before, which means that we need to have a resistor to limit the current that can make it to that LED. This means that each of these legs needs to have a resistor before it gets to the pin. In here I just jumped it over the center rail to make it look a little bit easier, and they are actually labeled with the correct color for what they are. I'm a little proud of that, I'm not gonna lie. So you can see here the left one is the red, hooked to pin 11. The next one is the green, hooked to pin 10. And the last one is the blue, hooked to pin 9. Take a few minutes to set this up, then we're going to jump over to the Arduino IDE and we will start to program this to actually make it light up. Here we are back in the Arduino IDE once again. I'm going to go through and set this up the way that I like it. Feel free to do that if you like or not, it doesn't matter. So the first thing we need to do is we need to set up our variables to hold on to our values of the pins, right? So these are variables to hold the pin values. Now what we've been doing so far is we've been doing an integer, and we'll call like the first one red. We'll call it red pin. And that will be equal to 11 because our red pin is the 11th pin. Easy enough. The main use for variables is to hold on to values. In programming, you end up setting a variable and changing it and doing things all the time. Some variables, however, are never going to change. In the middle of our program, we're not going to say that the red pin is no longer 11. It's going to be 11 forever. That means that it's going to be a constant. In programming, there's a special kind of variable called a constant variable, which you write const before the variable. And then that is telling the compiler when it's going that this value will never change. It doesn't need to keep track of it as closely as it does the other ones. And that makes our program run a little bit smoother, takes up a little bit less space, and just works a little bit better. So we're going to use constant variables for now to hold on to our constants. So we have green pin, and that's 12, and then constant blue pin, and that's going to be, we are actually 10 and 9, correct? Yeah. Change that to 9. All right. Okay, so those are our constant variables. The next step is, as we always do, we need to initialize things. I cannot type today, I apologize. Okay. So now, instead of having one pin, we have 3. So that can be 3 pin modes, right? We have red pin, pin mode, green pin, and pin mode, blue pin. There, so we finished our initialization, which is done inside of the setup. So now we have to set up our loop. The first thing we'll do is we'll just try to turn on the LED, right? We'll just make it easy. We'll try to make it red. So how do we do that? In order to make it red, we have to send a current through the red pin and no current through any of the other pins. In order to do that, we're going to use analog write. Because we use the PWM pins on the Arduino, we can use analog write, and that will allow us to send partial values later on. So if we want to make it, so if we want to make it fully red and partially green, we'll have the ability to do that. So right now we're just going to send full values. Red pin, because that's the one that we're turning on, and we want to turn it on fully, which is 255. Analog write green pin, that's going to be 0. And analog write blue pin will also be 0. When we first started, we don't necessarily need to set these as 0, but it's good practice to tell all of your things what to do in the loop at once. So that way every time it goes through, it knows exactly what it's doing. You don't have any problems from previous iterations changing things. So that's why it's a good idea to put all 3 of them in at one time. Now, we save this, go to verify. I have RGB demos, and we'll call this one Red Tutorial. We save it, we check to see if there's any errors. It's compiling, and we have no errors, good deal. Then what we do is we run it, upload it to our Arduino, and we see if it turns on. Now, as you can see, the light has turned red, and it does exactly as we are expecting. Good deal. So now what if we want to change the color? All right, so let's do like I said before, we want red full and we want green partially, okay? So we go in and we say green is at half. So now that we've set green to 128, that means it's half of the full amount. So that means that it is sending half of the full voltage. These pins output 3.3 volts, so that means we're sending out 1.65 volts. With 220 ohms, you can then do the math and realize that we are sending it half as much current as the other one, because I don't feel like doing the math to tell the exact amount. Since we are sending that half as much, it means that the green one should be half as bright as the red one. Now, this isn't going to be exactly the case, because the different LEDs inside are going to have different maximum brightness amperage values. There are 3 discrete LEDs inside of this. However, for our purposes, we can assume that they are all the same because the difference is going to be pretty marginal. It's just something to keep in mind if you want to have something that's very specifically the right color. Especially if you're trying to match something like a Pantone, that'd be a very good time to know those values. So we test our code again. It's done. We upload. You don't necessarily have to test it before you upload it. I often like to do that, but you don't have to. So now we see that it's turned kind of a sickly yellow color, which is sort of cool. So now we know how to make it turn colors. How can we do something interesting with it? We don't have to have the Arduino to do this. So why don't we set up something that would require the Arduino in order to make it work properly? So let's have it change colors. We'll start it out red, and then we'll put a delay of 1/4 of a second. And then we will change the color, and we'll make it, we haven't played with blue yet, so let's do that. So make it blue. So let's try that one. So we upload our code, and we see that it's only red. It's not supposed to be red. What's going on? Well, I forgot something. And this wasn't a learning experience. I actually did forget this. We need to put a delay for how long it will stay blue. We have it remaining red for 1/4 of a second. It turns blue, and then it immediately turned red again. There was no stop at the end, because remember, it loops constantly. So once we do this, we can upload it, and now we can see that it flashes between red and blue. So if you want to make a police car, here you go. You've got the code to make your police car. Now, you might have noticed it's kind of a pain to have to put these 3 lines every time we want to make a color change. There has to be a better way to do that. And in fact, there is. There's a standard idea in programming that if you continue writing the same lines of code over and over again, that you should make what is called a function to do that code for you. All a function is a batch of code that is stored, and then whenever you write the name of it with the parentheses, it executes that code. It is used in order to make code cleaner, so you don't get things lost, and it is made to do things that are done over and over again, such as we're talking about now. So here's how you make a function. The first thing you have to do is you have to declare what kind of variable the function will output. Not all functions output anything. A good example of this is the setup and the loop functions we've been using a lot. They don't actually output anything, they just do a lot of things. It doesn't actually return anything though, so they have a return type of void, which means that there isn't one. This will be the most common one that we use in our series, and we'll start with that. So we will have our function be void, and what do we want the function to do? We want it to change the color. So we're going to call it void change color, and then you need to have 2 parentheses. We will get to what the parentheses do here in a little while, but right now I'm trying to keep it simple to sort of step you into what a function is and how it works. It has its own set of curly brackets, and then you do what you want the function to do. Well, what we want the function to do is we want it to write out the color. So I'm just going to steal the code from up there, put it down here, and erase everything in here, okay? So now we have this function called change color. It's a good idea to name your functions in a descriptive manner. So we know that this changes the color. Functions typically are named with like verbs like change and those sorts of things. Much easier to keep track of what's going on then, and your code kind of reads in a way that makes sense. So how do we use this change color function? Inside our loop, we have to write the name of the function, which is change color, an open and a closed bracket, which is exactly as it is right here, and then a semicolon to end the line. So now that we've called our function, as it's running through the loop, it will do everything in order. So it goes through and it would execute any code that's above this. It gets to change color. It immediately jumps down and executes this line of code, and then this one, and then this one. So now that it calls change color, it will just immediately make the light red, and it will make the light red over and over again because of the loop. So let's test that. And now we see that the light has turned red, exactly as we were expecting. That's great. And it made our loop easier to read. It's not as cluttered, but it only makes it red. That's really not that helpful for us, is it? So what we can do is we can then go into our function here. Inside the parentheses, we can put what are called parameters. Parameters are variables that are created inside of the function that are sent to the function when you call it. I understand that's confusing sounding, but it'll make sense here in a second. So the first thing we have to do is we basically declare a variable inside of the parentheses. So we want an integer, and we're going to use the first one as red. Then we put a comma, and we can do another one. So we want red, green, and blue. And blue. So now we have these variables that the function is creating for us. We can then use those inside of the function itself. So we want the red value to be inside the red, then we want green, and then we want blue. So now if we test our code, we get an error. It says too few arguments. So what's happening is as you call the function, you have descended values for all of the parameters that it creates, these variables that we created right here. So now, in order to get this to work, we have to send it 3 integers, one for red, one for green, one for blue. So if we send it 255, 0, 0, we can then check it, make sure that it runs. It does, it compiled just fine. So let's look and try to figure out what this is going to do. We sent it 255, which is the value for the first one. They always go in the same order. 0 and 0. So it's 255 red, 0 green, 0 blue. That means when we have it actually go, it will send 255 red, 0 green, 0 blue. And as we upload it, we can see that it is now just turning on our red light. Okay, so we did the exact same thing we did before, but now we have the ability to change it. Okay, so let's say that we want to have it flash. So we do a delay. We'll do a quarter second because it looks nice that way. And then we can call the function again. This time we're going to go 0, 0, 255. We do another delay. Remember what we did last time is if we don't have a delay at the end, it will go from this line of code immediately to this one and we won't be able to see what's happening here. So we run the code and we once again see that we have our red and blue flashing police lights. Nice. So now we can see that we were able to do this in 4 lines of code inside of our loop rather than the 8 lines of code it took before. It took half as much code inside of the loop, and our function only has 3 lines inside of it, meaning that we were able to turn that 8 lines of code into 7. Not a huge decrease, but this decreases almost exponentially. So now we can add as many as we want, right? So we can come through here and add a bunch of them, right? And then just start putting values, right? So we have 150, 120, 110, 255, switch it to there, 0, 255. I'm making up values randomly as I go, 180 and 12, right? So we can do this, and then if we compile the check to make sure I didn't copy and paste wrong, good. Then we upload it to the Arduino, and you can see it's now flashing through all of these different colors that I put on here. And think about how many lines of code we changed. Each time that there's one of these, we used 3, but now we use 1, so there's a third as much. So I think this does a good job of demonstrating how much time you can save by having good functions. Not only that, but see how much more readable our code is here because we have this function down at the bottom that takes care of things for us. It makes the code much easier to read through and understand what's going on. So instead of seeing random analog writes over and over again, I see something, I'm changing color to this, changing color to that, changing color to this, and over again, it makes sense. There's one other thing that we forgot to do, and that is we need to put a comment at the beginning of our function to tell us what the function does. Otherwise, it's difficult to remember. Yes, this is a very simple one, but as I said before, it's good to get into the habit, especially as your functions get more and more complicated. So this function will change the color with the red, green, blue value that is passed to it. So now you know how to control RGB lights with an Arduino. This is my second video in my Learn to Arduino series. The third video will be covering buttons, and if you happen to miss the first one, check out the link underneath the little eye in the top right corner there. These videos will be released every Monday, and the next one will be in buttons. I hope to see you then.